Welcome back all of you to another lecture of engineering physics for the BTech first year students, and the code of the subject, again I am reminding you, it is BAS 101. Today we will be talking about the fifth unit of this subject, and the unit is laser and fiber optics. And in this unit I will be discussing about types of laser. So we will start our discussion. First, although we will be talking about the types of laser, but we just want to define laser. So how do we define laser? Laser are the sources of a special form of light. The word laser is a short form for this term, light amplification by stimulated emission of radiation. So a device which is giving out this type of light, that will be falling in the category of lasers. So this is just a primary term to understand what we will be talking about. All right. So next, so this is, we have already discussed, a laser is a device in which we use the process of stimulated emission to amplify the infrared, visible or ultraviolet electromagnetic radiation. That means how we achieve this term, light amplification, that is mentioned here, that first we generate a process of stimulated emission, and then by the stimulated emission, the radiation which we are getting, that we will amplify. So in that way we will be having the amplified beam, and that we will consider as our laser beam. So this beam can fall in the region of infrared part of the radiation, visible part of the radiation, or the ultraviolet part of the radiation, depending on what material, what sources we are using for the laser. All right. So again we come to our specific type of laser, like types of laser which we are discussing in this first year syllabus. So that is a ruby laser. This is the first type of laser. So we must know that what type of laser it is. So it is a solid state laser. All right, it is falling in the category of solid state laser because the medium which we are using, that is having a solid form. All right. So and it is generating a light which is having this wavelength 694.3 nanometer. All right. So this type of laser beam, this wavelength of laser beam will be generated from the ruby laser. All right. Now when we discuss more about ruby laser, so we will first talk about the construction part of the ruby laser. So if we look at the construction part, so it is having three important elements in the construction part. We are having the laser medium, we are having the pumping source, and we are having the optical resonators. Every part in the laser is playing its role. So first we will discuss about the laser medium. All right. So here you can see laser medium is also known as the gain medium. All right. So what is happening in this medium? What actually the things are included in this medium? Here in this medium we are having a single crystal of ruby which is comprising of aluminium oxide and chromium ion. All right, in the form of cylinder, and this combination, it acts as the laser medium or the gain medium. All right, if we so it means that it is this part which will be forming the laser beam. It is this part which will be taking part in the formation of the laser beam. That is why it is also defined as the gain medium. All right. So this is about the gain or the laser medium. All right. So now we will go to the what happens when the aluminium oxide and the chromium ions are present here. All right. So the chromium ions, they are replacing this aluminium from this oxide in this ruby rod. So this is the construction part. This is the pink colored ruby rod, and the pink color is because of the chromium ions. All right, in this ruby rod itself, we are having a mixture of aluminum oxide and chromium ions. All right, and then we are having these mirrors. So they are behaving like the optical resonators. We are having two of these mirrors on both the sides of the this ruby rod. So these mirrors are responsible for reflecting the light beams. If we are looking at this mirror, so it is a partially silvered mirror. It will be reflecting the light partially, and it will be giving out the laser beam. So this is the function of the partially silvered mirror. And then we come to the totally or the fully reflecting mirror. So it will be reflecting the laser beam completely. That means no part of the laser beam is able to come out of the device from this mirror. And here we are having the flash tube. All right, you can see that the radiations, these green arrows are showing the radiations which is falling from the flash tube. So when we were discussing actually this part, this pump source part, all right, the laser medium part we have discussed. So when we come to the pump source part, so this pump source part is shown here in terms of the flash tube. So the role of the pump source part is that it is giving out the radiation to excite the atoms from this laser medium. All right. So this is the role of the this pump source. And then here again we are having the optical resonator. So these optical resonators, these consist of a pair of mirrors. One of the mirror is partially reflecting, I have already told you, because so that when the laser beam is generated inside the device, so it can come out from this partially silvered mirror. The next is the totally reflecting mirror, so that no part of the beam is emitted from this side. Only one side the beam can come out. All right. So this here the detailed working of this entire construction is given, which we have already discussed here. All right. So now after talking about the construction, we can come to the working of the laser. When we are discussing the laser, we will talk about its construction, its category, which category it is falling, like the ruby laser is falling in the category of solid state laser. All right. Now we will study about the working. So whenever we study about the working of the laser, so we take the help of these energy level diagrams. All right, where the we can see the energy levels are drawn and the atoms are drawn, and the movement of the atoms is shown, and how the movement of the atoms is generating the beam. So that is shown in the energy level diagram, and with the help of the energy level diagram only we can understand what mechanism is happening when the laser beam is formed. So this is step number 1. We start with this step. So what happens when that pump source, all right, I forgot to tell you about the pump source, the name of the source. Like here the laser medium is this ruby rod. All right. Similarly, the pump source is the xenon flash tube. All right. So the pump source is the xenon flash tube generally. This is the xenon flash tube which is used in the ruby laser. Here you can mention it. And when you look at the diagram, so then here also you can understand, because this green light is because of that xenon flash tube. All right. So the xenon flash tube is emitting radiations, and these radiations are falling on that ruby rod. So inside the ruby rod, we have already seen that the chromium atoms are free. So they are free and they are at present in their ground state. So when the radiations from the xenon flash tube is falling on these atoms of the chromium, so they absorb this radiation. All right. So they absorb this radiation and they start moving in the higher energy levels. Alright, so some of the atoms are moving in this higher energy level, which is E2, alright, and then remaining atoms are moving to the other higher energy level, which is E3. Alright, so since E3 is at a higher level as compared to E2, so we can call it as the excited level or the excited energy state. So the atoms are moving faster in the excited energy state as compared to this one, E2. Alright, and what happens, this energy state is having a particular lifetime. It means that the atoms will be able to stay in this energy state during that time only. So this energy state is having a lifetime of 10 to the power of say -8, alright, seconds. So this is a small time. So what happens when the atoms are moving from the ground state, this E1 lower energy state, or it can be the ground state. So when they are moving from the ground state or the lower energy state to this E3, so then since the lifetime of this energy level is very small, so the atoms are unstable here. And when they are unstable, so by different means they try to give out their energy, alright, and so that their energy is less and they can obtain a stable value of energy. So in this process, in giving out the energy process, their energy from E3 reduces to E2 and they start coming to the energy level E2. Alright, now it is very interesting to note here that E2 is already having some atoms present and E2 is also having atoms from E3. So now slowly with the time, the number of atoms in this energy level E2, they start increasing, alright, as compared to this energy level E1, alright. This is the lower energy level as compared to E2. So E2 is having larger number of atoms as compared to the lower energy level E1. Alright, now this condition is known as the condition of population inversion, because what happens, generally a lower energy level is having large number of atoms, because the atoms prefer a stable energy. So that is why a lower energy level will have a large number of atoms, whereas a higher energy level will have a low number of atoms. But in this case, we are able to see that a higher energy level is obtaining large number of atoms. Suppose the number of atoms in the E2 energy level are denoted by N2 and the number of atoms in E1 energy level are denoted by N1. So in this case, we find that N2 is greater than N1. So this is how, so which is in the normal, which is different from the normal case. So that is why this situation is termed as population inversion. Population is being inversed. A larger energy level is having a large number of atoms. Alright. So this condition is obtained here. Now this condition is a very important condition in order to generate a laser beam, alright, and it should also be noted that if this energy level E2 was not present in this chromium, so then what happened, no condition of population inversion would be obtained. So we must understand that this energy level E2 is having a very important role in the generation of this population inversion and hence in the generation of laser beam. Now, this energy level E2, it is lying between the lower energy level and the excited energy level. And that is why it is given a particular name. So, that name is known as, it is called as the metastable state. Alright. It is called as the metastable state. This part. Alright. So metastable state and the population inversion, these two are the requirements so that we can generate a laser beam. If this metastable state is not there, so atoms will not stay anywhere. So, they will never increase in number. So, they will never obtain this condition. Alright. So, that is the role. Alright. So, now what happens? Now we must understand that when the atoms start collecting here in this state, alright. So, then since N2 is greater than N1, alright, if by some means one of the atoms starts coming down, if one of the atoms starts coming down, so then the atom here, if one of the atom starts coming down, so it will give out certain energy, alright, and this energy will be equal to E2 minus E1, alright, certain radiation it will give out, and this will be equal to this E2 minus E1. Now, this radiation or the energy will be absorbed by these atoms, these atoms, and all of these atoms, they will start coming down simultaneously, emitting the same type of radiation which was emitted by this atom. Alright. That means this atom has induced or has stimulated the other atoms, and they also start coming down to the lower energy state by emitting certain amount of radiation. Alright. Now, this radiation which is emitted by these atoms, this radiation is traveling inside, it is here, it is traveling here, this is the radiation, it is generated here, and so it is traveling inside this ruby rod, alright. And what happens? It is hitting this partially silvered mirror, then it is moving back, it is hitting this one, then it is moving back. So, it is traveling to and fro inside this ruby rod, and since this radiation individually is not very powerful, it is very small, so that is why it will keep on moving inside this ruby rod until its energy is increased or it is amplified. So, now comes the role of these reflecting mirrors, or these are the optical resonators. So, now comes the role of these parts. So, what happens when the radiation hits these mirrors? In every hit, the radiation amplifies. Alright. So, and this process continues. So, when it is highly amplified, so the radiation, you can see it starts coming out. When it is highly amplified, so it comes out from the partially reflecting mirror, and it is this radiation which we call as the laser beam. Here in our case, we are having the laser beam generated. This output which is coming out in the form of highly intense amplified beam. So, that is our laser beam generated by the ruby laser. Alright, so it is a red colored beam which is coming out. So this is how the ruby laser, this device is constructed, and this is how it is working and giving out the laser beam. Alright, so the construction, by looking at the construction and the working and the energy level diagram, we can understand how the ruby laser is working and giving out the laser beam. So, alright, and we can also understand that how the population inversion condition, how the metastable state, they are playing the role in this laser. Alright. So, this is one type of laser which we have discussed, and if we talk about the what category it is falling in, so it is falling in the solid state category, and in the energy level diagram also, if we look at the energy level diagram also, we can categorize its type, like we are having this lower energy level, this metastable state and this excited state. So, we are having 3 energy levels. So, that is why it is a 3 energy level laser, 3 energy level laser. This is also the name given to the ruby laser. ठीक है? Alright. So, then now we can talk about the other type of laser, which is the helium neon laser. You can see that it is mentioned, it is a gas laser, and the laser medium which we have discussed, laser medium which is involved here is helium and the neon gases, or we can say they are the gain medium also. So, now we can understand that what is the role of the laser medium or the gain medium. They are actually the part which are generating the laser beam. Alright, so helium neon laser is also falling in the category of continuous wave type of laser. If we talk about this, so we can define about the ruby laser also. Ruby laser was falling in the category of this is falling in the category of a continuous wave lasers, while ruby laser was falling in the category of it is not giving a continuous wave, it is a pulsed laser. Alright, like what is the meaning of this? Like here, when we discuss the output of the ruby laser, so we are having this, it's a pulse, and then after some time we are having nothing, and then again we are having a pulse, and then we are having a nothing. So, it is a pulsed laser. Alright, ruby laser is a pulsed laser. So, we can have a pulsed laser also, we can have a continuous wave laser also. So, this is how the ruby laser is giving the output, whereas a helium neon laser, it will give a continuous wave output. So, that is why it is falling in the continuous wave laser. Alright, so we will start our discussion with the construction of the helium neon laser. Alright, and we must note that it will give a laser beam which is having a wavelength 632.8 nanometer. So, this type of measurement of wavelength it will give out. Alright, it will be red in color, and it is mostly preferred in the experiments. So, helium neon laser has a benefit on the ruby laser, that mostly this laser is preferred in the experiments, because you can see it is written continuous wave laser. So, the experiments, some experiments may take a long time. So, then we require some laser beam which is available for a long time interval. So, we start with the construction part. So, this diagram is giving us the construction part of the helium neon laser. You can see that we are having a glass tube in this laser, and in the glass tube we are having a mixture of helium and neon gas. Now, the mixture is in some ratio. So, at some places in some of the helium neon laser, the mixture is having this ratio, and in the other it is having 7:1 this ratio. That means the ratio is helium is to neon. all right. So, it is having this type of ratio. And then what happens? Now, this is the gain medium or the active medium or the laser medium, helium neon gas mixture. The next part of the laser was what? The next part of the laser is the energy source, all right, or the pump source. So, the energy source or the pump source in the case of helium neon laser, this is the DC power supply, all right, which is given, which is, that means a voltage is supplied, all right. So, this is the energy source for the helium neon laser, and the next is the optical resonators. So, these are the optical resonators at the ends of the glass tube, all right. In this part, it is given as the output coupler. It means that this is similar to the partially reflecting mirror which we had in the ruby laser. And in this highly reflector means that the totally reflecting mirror, again we have it in the ruby laser. So, these are the optical resonators, all right. We can mention here that these are the optical resonators. So, this is the optical resonator, all right, and this is the active medium or the laser medium. We can write this at laser medium, and this we can write as the pump source or the energy source. So, these are the main parts of the laser, how they are categorized. Now, we will discuss how the working is going on. So, as we can see that we are having a DC power supply. So, when we use this power supply to this glass tube, the electrons are traveling inside this glass tube and they are interacting with the helium neon gas mixture. And when they are interacting with this mixture, they are increasing the energies of the helium and the neon. All right. So, that means the electrons transfer their energy to the helium and the neon. And with the help of that energy, the helium and the neon gases, they obtain larger energy values. All right. And they produce laser beam, and then the role of the optical resonators come. So, we will look at the energy level diagram for the helium neon like this. All right. So, this is the energy level diagram for the helium neon laser, and here you can see it is the energy level diagram of helium and how when the electrons are interacting with the helium. So, how the helium is moving from the lower energy level to the higher energy level, and the value of the energy level is also given, that is 20.61 electron volts. So, this energy value is obtained by the helium, all right. And when the helium is having this large energy value, so then the helium is again interacting with the neon and transferring its energy to the neon, all right. And neon is getting extra energy from the electron which has come from the power supply, all right. So, then neon is also moving from its ground state to the higher energy state, which is having the value 20.66 electron volts. So, and this value is larger than 20.61 electron volts, which is for the helium. So, this difference of 0.05 electron volts, this is transferred to this helium. So, again helium rises from its ground state to the higher energy level. Now, what does it do? When it moves to the higher energy level, so neon atoms which are present in this ground state, so it interacts with these ground state atoms, alright, and it increases their energy and it sends those atoms to the higher energy state. So, what happens in this process? The number of atoms in this higher energy state for the neon, they start increasing, because by themselves also they are moving and they are moving with the help of helium also. So, therefore, the number of atoms in this higher energy state starts increasing, and slowly this energy state is highly occupied. Alright. So, here we must also understand that this helium atom, this helium gas is only used as a catalyst. Alright, it is not taking part in forming the laser beam. It is only behaving like a catalyst for the neon gases, so that the neon gases, the atoms of these gases, they are moving to the higher energy level and taking part in the generation of the laser. So, then when this energy level is highly occupied, so the condition of population inversion is obtained. Alright, here, and this condition, when it is obtained, so the necessary condition for laser is fulfilled now. What will happen? Again, one of the atom will come down, it will give out the radiation. This radiation will stimulate the remaining atoms which are present here. They will also absorb this radiation, they will start coming down simultaneously and giving out this same radiation. So, these radiations will be our laser radiations once they are amplified. Like here, they will be traveling inside this. These radiations will be traveling in this glass tube. They will be hitting these reflectors and they will be amplified. When they will hit the reflectors, they will amplify. When they will be highly amplified, they will come out from one of the reflectors in the form of laser beam. And in the case of helium neon laser, it is this wavelength of laser beam which is generated. Then the atoms which have generated this laser beam, the atoms will come down to this energy level, lower energy level. They will again lose some energy. They will come down to this again a next lower energy level, and finally they will come down to the ground state. In these type of transition, they will not emit any radiation. And this process will take place gradually, slowly they will lose energy and they will come down. What will happen then? When they come down to this ground state, again they will be meeting this helium, and again the helium will be transferring its energy, and again they will move on to the higher energy state. So, this process will continue. So, that is why the output which we are getting will continue, and that is why it will be a continuous output. That is why this laser, helium neon laser, is giving us a continuous output. Alright. So, this is how the working of the laser beam is done. So, since it is giving us a continuous output for the same energy level, so that is why it is better than the ruby laser. And the continuous output it is able to get because of these energy levels. So, how many energy levels? 1, 2, 3, 4. So, 4 energy levels this type of laser is having. So, it is called, because neon is having 4 energy level. Remember, this is the catalyst. So, 4 energy level laser, this is also called a 4 energy level laser. So, we can understand how the 4 energy level laser is giving us a better performance than the 3 energy level laser. Alright. and the disadvantages. So if we discuss about the advantages or the applications, so they are used in industries. Remember, we have discussed that they are giving a continuous output, so they can be used for a long term. They are used in scientific instruments, they are used in college laboratories, we are having experiments on those. Alright, disadvantages of the helium neon are low efficiency, the intensity which they are giving out, and low gain, and they are limited to low power tasks. Alright, so wherever we are not having experiments which are based on efficiency or where large gain is required, so there we can use this. Alright. Where we require more efficiency or more gain, then there we can refer to the ruby laser. So in this way, it was a small description about the two types of laser which is in our course, the helium neon laser and the ruby laser. Alright, so I hope you must have got an idea about these types of laser, and we will discuss some more parts of these laser in the other lecture. Alright, that is all for today's discussion. Thank you.